Hi everybody, I'm Chris Collison and we're going to now talk about part 2 of the experiment Thermochemistry to the Rescue. And in this part you're going to move further along in your quest to build a prototype to save someone from frostbite. You're going to identify the best salt to use, the best raw material to use for your prototype. So let's go take a look and figure out how we can determine that best salt to use. So this part is titled Portable Heat Pack Thermodynamics, but essentially you're going to determine the enthalpy of solution, the enthalpy of the reaction for dissolving certain salts, so you can determine how much heat is released and whether that heat will be enough for your heat pack. So again, I implore you to be ready when you come into lab. So first of all, we're going to try 3 different salts. We're going to work with sodium chloride, we're going to work with potassium chloride, and we're going to work with calcium chloride. You're going to have some pre-lab work to do. Make sure you've done that ahead of time. But back to the actual experiment here. You're going to now work in a test tube. So you'll have 2 test tubes, one with a probe in. So you put your probe in the test tube with about 2 milliliters of water in here. And it's going to be water from your room temperature stabilized beaker. You can take a second test tube, and in this test tube, you're going to have some of your salt. And what you're going to do is add that salt to the water. And before you've done that, of course, you will need to have recorded a stable initial temperature of that water. And again, it should be fairly stable. But remember, you're putting that water into a room temperature test tube. So as materials come in contact with each other, heat ends up being exchanged. So make sure you have a stable initial temperature before you add the salt. So in the first case, we're going to add sodium chloride to the water, and you're going to monitor and record the change in temperature. You're going to repeat the same process, very quick process, so you can set all 3 up at the same time with the disposable test tubes. So set this up, and what you're going to do is determine which salt would be best for use in a heat pack. So if you're always working with about 2 milliliters of water in the bottom of your test tube, and you're always adding about the same mass of sodium chloride, then you'll basically be able to figure out which one gives off the most heat and which one will be the best for your heat pack. Step 2, we come back to our coffee cup calorimeter, and you're going to do a quantitative analysis now of the dissolution of one of these salts. So the salt that gives you the highest temperature increase is going to be the one that you want to use. So make sure again you replenish your coffee cup calorimeter with a known amount, 100 milliliters in the first case, of water from your beaker, and make sure you can measure a stable initial temperature. Then what you're going to do is precisely weigh some amount of the chosen salt. So somewhere between 8 grams and 12 grams, but you've measured it accurately and precisely. If it's 9.24, that's fantastic. If it's 11.52, that's fantastic. But just make sure you precisely measure that mass and record it. So when your temperature is stable with your coffee cup calorimeter, you're going to pour the salt in. And then ultimately the temperature of that solution is going to change. Remember, you've got your stir bar at the bottom of the coffee cup calorimeter. So as that salt starts to dissolve, the temperature is going to change. Now remember, you have a reaction that's releasing heat, and that reaction that's releasing heat is going to give you a heat value of the water in here. In fact, this Q water is going to be, it's minus Q water equals Q reaction, and Q reaction equals the delta H of reaction. So minus Q water equals Q of reaction. Small typo there, very important, and we can now see how important it is to reflect on what signs we use in our equations. So we're also going to make the assumption that Throughout this experiment, the specific heat capacity of the solution and the water is equal to 4.18 joules per gram per degree Celsius. When you've done that for 100 milliliters, repeat this procedure first with a 70 milliliter beaker of water or a coffee cup calorimeter of water, and then use a 50 milliliter amount of water. Use a similar mass of salt each time. Each time, though, you weigh out precisely the mass that you're adding to your coffee cup calorimeter. So replenish the water and then add a known mass of salt each time. As I will show you in the Excel spreadsheet, you're going to solve for the delta H, see the enthalpy change of the reaction, and then calculate the enthalpy change of reaction per mole of salt. And that's it. If you are well prepared, this particular experiment will flow fairly smoothly. Set up your tasks within your team to get through this quickly and efficiently. So, on to the next step, the final step, as you look to build your prototype for your heat pack. Thank you for your attention.